The moon has always been a symbol of mystery and untapped potential. But what if its barren surface could transform into a bustling metropolis? Right now, in labs and research centers around the world, AI-powered robots are being designed to do just that: construct entire cities on the lunar surface, paving the way for a future where humanity isn't confined to Earth. This isn't just a dream anymore, it's a tangible goal backed by groundbreaking technology. In this video, we'll uncover how these robots are redefining space exploration, from their ability to operate in extreme environments to the advanced AI systems that guide every move. What does it take to build a city on the moon? What challenges must we overcome? And what incredible possibilities await us? Join us as we explore how science and innovation are turning this once impossible vision into a reality, and how humanity is poised to take its next giant leap. Building a city on the moon might sound like something straight out of science fiction, but it's a vision that's becoming increasingly tangible. Imagine vast domed habitats, their surfaces glinting in the sunlight, designed to shield inhabitants from the moon's harsh environment, extreme temperatures, radiation, and the vacuum of space. Or picture intricate networks of underground tunnels carved into the lunar rock, offering natural protection and stable living conditions. These structures wouldn't just be technological marvels, they'd represent humanity's first step toward becoming a multi-planetary species. Why take on such an ambitious goal? The reasons are as diverse as they are compelling. For starters, the moon offers a unique laboratory for scientific research. Its low gravity and lack of atmosphere allow for experiments that would be impossible on Earth, from studying the effects of long-term space habitation to advancing our understanding of the universe. The moon is also rich in resources like helium-3, a rare isotope that could revolutionize clean energy, and metals that could be mined to support both lunar and Earth-based industries. But perhaps the most exciting reason is the moon's role as a proving ground for future missions to Mars and beyond. By building and sustaining a lunar city, we'll develop the technologies, systems, and expertise needed to tackle the even greater challenges of colonizing other planets. The moon, in many ways, is our stepping stone to the stars. This grand vision, however, hinges on one critical factor: AI-powered robots. Constructing a lunar city is no small feat, and human labor alone simply isn't practical given the risks and limitations of working in space. Robots equipped with advanced artificial intelligence can perform tasks like construction, resource extraction, and maintenance with precision and efficiency, all while operating in environments that would be deadly for humans. They're not just tools, they're the backbone of this audacious endeavor. As we look to the moon, we're not just imagining a new kind of city, we're envisioning a new chapter in human history, one where AI and robotics play a central role in expanding our horizons beyond Earth. Artificial intelligence has quietly become the unsung hero of space exploration, transforming how we venture beyond Earth. Think about it. Space is a realm of infinite unknowns, where human presence is limited by harsh conditions and vast distances. That's where AI steps in, offering capabilities that are nothing short of revolutionary. Take autonomous rovers like those on Mars, for instance. These machines don't just follow pre-programmed instructions, they analyze their surroundings, avoid obstacles, and even decide which rocks are worth studying. All of this happens in real time, millions of miles from any human operator. But AI's role doesn't stop at planetary exploration. Satellites orbiting Earth rely on AI to navigate, adjust their trajectories, and process massive streams of data. Whether it's mapping the moon's surface or predicting solar storms, AI's ability to sift through information faster than any human mind makes it an indispensable tool. And let's not forget its adaptability. In the unpredictable environment of space, where a single malfunction can derail an entire mission, AI systems can troubleshoot issues and adjust strategies on the fly. What's truly exciting is how AI and robotics work together. Imagine a swarm of robots building a lunar habitat, each one equipped with AI that allows it to collaborate with its peers, share data, and solve problems autonomously. This synergy isn't just theoretical, it's already being tested in prototypes designed for future lunar missions. AI's ability to process complex data sets and make split-second decisions ensures that these robots can handle the challenges of constructing cities on the moon, from laying foundations to managing resources efficiently. This combination of AI and robotics isn't just about technological advancement. It's about expanding possibilities. It's about creating systems that can thrive in environments where humans can't yet. As we look ahead to building cities on the moon, AI isn't just a tool. It's the backbone of a new era in space exploration, one where the lines between science fiction and reality blur in the most extraordinary ways. Building a city on the moon might sound like science fiction, but it's quickly becoming a tangible reality thanks to robotic construction crews. Picture this, a team of AI-powered robots, each with specialized skills, working in perfect harmony to turn the barren lunar landscape into a thriving metropolis. These machines aren't just tools, they're the architects, engineers, and laborers of the future, designed to tackle the unique challenges of building in such an unforgiving environment. One of the biggest obstacles is the moon's extreme environment. Temperatures can swing from scorching highs to bone-chilling lows in a matter of hours, making traditional construction methods nearly impossible. Add to that the moon's low gravity, which affects how materials behave, and you've got a puzzle that requires innovative solutions. That's where robotic construction crews come in. These machines are built to withstand the harsh conditions, using advanced materials and cutting-edge technology to perform tasks that would be too risky or inefficient for humans. What's truly remarkable is how these robots work together. Imagine a high-tech dance where every step is choreographed by AI. One robot might use precision tools to dig foundations, while another assembles prefabricated modules with pinpoint accuracy. Some robots could even 3D print structures using lunar regolith, the moon's dusty surface material, turning the very ground beneath them into building blocks for the city. This level of coordination isn't just impressive, it's essential for creating a sustainable lunar habitat. The potential for robotic construction on the moon is staggering. Beyond just building shelters, these robots could lay the groundwork for everything from power grids to transportation systems, paving the way for a fully functional lunar society. And while the challenges are immense, so are the opportunities. With every structure they assemble, these robots bring us one step closer to making the moon not just a destination but a home. Picture a bustling construction site on the moon, but instead of hard hats and heavy machinery, it's populated by sleek, AI-powered robots working in perfect harmony. These machines are far more than just tools, they're the architects, builders, and laborers of tomorrow, designed to tackle the unique challenges of lunar construction. Among them, autonomous excavators take the lead, using advanced sensors to analyze the moon's surface and dig with precision, preparing the ground for the structures to come. These excavators don't just move dirt, they map the terrain in real time, ensuring every scoop is optimized for stability and safety. Working alongside them are massive 3D printers, capable of crafting entire building components from lunar regolith, the dusty, rocky material that blankets the moon's surface. By turning this abundant resource into durable construction materials, these printers eliminate the need to transport heavy supplies from Earth, making lunar cities not only possible but sustainable. Meanwhile, assembly drones zip through the air, equipped with precision tools to weld, bolt, and connect structures with accuracy that surpasses human hands. These drones are more than just fast, they're intelligent, capable of adapting to unexpected challenges on the fly, thanks to their AI-driven decision-making. But what truly sets this robotic workforce apart is their ability to collaborate seamlessly. AI acts as the invisible conductor, coordinating their efforts to ensure every task is completed efficiently and without human oversight. They don't just follow commands, they learn, adapt, and improve over time, making them invaluable partners in the mission to create a livable environment on the moon. Together, these robots aren't just building cities, they're laying the foundation for humanity's future in space. Imagine a world where the very dust beneath your feet becomes the foundation for towering structures and sprawling cities. That's the revolutionary power of 3D printing on the moon. This isn't science fiction, it's a technology that's already being developed to turn lunar regolith, the fine layer of dust covering the moon's surface, into building materials. AI-powered 3D printers could be game changers, enabling us to construct habitats, roads, and entire infrastructure systems directly on the lunar surface. Here's how it works. Lunar regolith is rich in minerals like silicon, iron, and aluminum, which can be processed and compacted into solid structures. AI systems would analyze the composition of the regolith, optimize the printing process, and ensure precision in every layer of construction. This approach eliminates the need to transport heavy building materials from Earth, drastically reducing costs and logistical challenges. But the benefits go beyond efficiency. Using local materials means we can build faster and more sustainably, paving the way for long-term lunar settlements. Think about it. Instead of relying on Earth for supplies, we could create entire cities from the moon's own resources. This technology could also adapt to different environments, constructing everything from protective habitats to radiation shields and even energy-generating structures. The potential is enormous. With 3D printing, lunar development could shift from a slow, resource-intensive process to a rapid and scalable one. It's not just about building shelters, it's about creating a blueprint for how humanity can thrive in space, using the tools and materials available in our cosmic backyard. The moon could become a proving ground for technologies that might one day shape the future of interplanetary exploration. When it comes to building cities on the moon, one of the most pressing challenges is figuring out how to keep the lights on. Energy isn't just a convenience, it's the foundation of everything: life support, communication, construction, and more. But here's the catch: the moon doesn't have the same resources we take for granted on Earth. No fossil fuels, no wind, and no consistent atmosphere to carry energy. That's where AI-powered robots step in, offering solutions that are as innovative as they are essential. Take solar power, for example. The moon's surface is bathed in sunlight for about 2 weeks at a time, making solar panels a natural choice. But unlike Earth, the moon's environment is harsh. Think extreme temperatures, micrometeorite impacts, and abrasive lunar dust. This is where robots guided by advanced AI come into play. They can install solar arrays with precision, adapt to the terrain, and even clean or repair panels to maintain peak efficiency. And because these robots are autonomous, they can work around the clock without human intervention, ensuring a steady flow of energy during those long lunar days. But what happens during the moon's 2-week night? That's where things get even more fascinating. Scientists are exploring options like nuclear reactors, specifically small modular designs that could provide continuous power regardless of sunlight. Here, AI plays a critical role in managing these systems, balancing energy production and ensuring safety. Robots could handle the installation and maintenance of these reactors, working in environments too dangerous for humans. What ties it all together is AI's ability to manage these diverse energy sources as one cohesive system. Think of it as a lunar power grid where AI constantly monitors supply and demand, predicts usage patterns, and even preemptively addresses potential issues. This isn't just about keeping the power on. It's about creating a resilient, sustainable energy infrastructure that can support a thriving lunar city. Energy is the lifeblood of any city, but on the moon, it's a matter of survival. With AI and robotics working in harmony, we're not just solving a technical challenge, we're laying the groundwork for humanity's next frontier. And as these systems evolve, they'll set the stage for even more ambitious projects, from lunar industries to deep space exploration. Water is the lifeblood of any sustainable habitat, and the moon, once thought to be a barren desert, might just be hiding a treasure trove of this vital resource. Recent discoveries have revealed that lunar ice deposits exist in permanently shadowed craters at the moon's poles. These icy reserves could hold enough water to support human life and fuel future exploration. But how do we access it? Enter AI-powered robots designed to navigate the moon's harsh terrain and pinpoint these hidden reservoirs with precision. These autonomous machines are equipped with advanced sensors and algorithms, allowing them to map subsurface ice and determine the most efficient extraction points. Using drills and heating systems, they can melt the ice and collect the water without disrupting the surrounding environment. This process isn't just about survival, it's about creating a foundation for long-term lunar development. Once extracted, this water can be processed for drinking, used to grow crops in lunar greenhouses, or even split into hydrogen and oxygen to produce rocket fuel. Imagine a lunar colony where water isn't just a necessity but a resource that powers exploration deeper into our solar system. This isn't science fiction, it's a vision that's rapidly becoming possible thanks to cutting-edge technology and the ingenuity of AI-driven systems. Picture this, a bustling lunar city, robots working in harmony, habitats humming with activity, and Earth sending critical updates, all seamlessly connected. But how does this intricate web of communication function in such an extreme environment? Enter AI, the mastermind behind designing and deploying lunar communication networks. These systems are the lifelines of any future lunar city, ensuring that every robot, every module, and every piece of data stays in sync, no matter the distance or the obstacles. One of the first challenges AI must tackle is the moon's lack of atmosphere. Without it, traditional radio signals can face interference or degradation over long distances. AI-driven solutions could deploy a network of lunar satellites, forming a constellation that blankets the moon's surface with uninterrupted connectivity. These satellites would act as relay points, bouncing signals between robots, habitats, and Earth in real time. Think of it as a lunar internet, but one designed specifically for the unique demands of extraterrestrial life. But the moon's harsh environment doesn't stop there. Dust storms, extreme temperatures, and the lack of a magnetic field all pose significant risks to communication equipment. AI could play a pivotal role in designing resilient systems, ones that self-diagnose issues, repair themselves, or redirect signals seamlessly when disruptions occur. For example, if a lunar rover ventures into a shadowed crater and loses connection, the AI network could instantly reroute data through another satellite or nearby robots, ensuring no interruption in mission-critical tasks. Another fascinating aspect is the role of AI in managing the sheer volume of data. With dozens of robots working simultaneously, habitats monitoring life support systems, and Earth sending new instructions, the network must prioritize and streamline information flow. AI algorithms could analyze the urgency of each data packet, ensuring that the most critical messages, like an alert about a habitat's oxygen levels, take precedence over routine updates. Of course, maintaining this network isn't just about technology, it's also about scalability. As the lunar city grows, so too must its communication infrastructure. AI could oversee the expansion, determining the optimal placement of new satellites, antennas, or relay stations based on real-time usage patterns. This adaptability ensures that the network remains efficient, even as the city evolves from a small outpost to a sprawling metropolis. The beauty of this AI-driven communication network lies in its ability to connect not just machines but people too. For the astronauts and engineers living on the moon, staying in touch with Earth isn't just a convenience, it's a lifeline. Whether it's a video call with loved ones, a live update from mission control, or a scientific collaboration with researchers back home, these networks make the moon feel a little less like a distant frontier and a little more like an extension of our world. Navigating the moon's surface is a monumental challenge, but AI-powered robots are up to the task. Equipped with advanced sensors like LiDAR, radar, and high-resolution cameras, these robots can scan the environment in incredible detail. They use this data to create precise 3D maps of the lunar terrain, identifying obstacles, craters, and unstable surfaces. These maps are essential not just for movement, but for planning and executing construction projects safely and efficiently. What makes this possible is the sophisticated algorithms these robots rely on. Using machine learning and real-time data processing, they can analyze their surroundings and make split-second decisions about where to go and how to avoid hazards. This level of autonomy is crucial because communication delays between Earth and the Moon mean that human operators can't always guide them in real time. Instead, the robots must think for themselves, adapting to unexpected challenges as they arise. Accurate mapping isn't just about avoiding danger, it's also the foundation for building lunar cities. Knowing the exact topography of the moon's surface allows robots to determine the best locations for structures, roads, and infrastructure. It ensures that every piece of the city fits together seamlessly, even in an environment as unforgiving as the moon. Without this capability, constructing anything beyond the most basic shelters would be nearly impossible. Safety is another critical factor. The moon's surface is littered with jagged rocks, deep craters, and shifting regolith. A misstep could damage equipment or jeopardize an entire mission. By mapping every inch of their surroundings, AI-powered robots can move with confidence, reducing the risk of accidents and ensuring that the work progresses smoothly. This combination of precision, adaptability, and safety is what makes autonomous navigation a cornerstone of lunar exploration and construction. Picture this: a team of astronauts stationed in a lunar habitat, orchestrating a symphony of robots as they assemble structures, mine resources, and prepare the moon for human habitation. While AI-powered robots are equipped to handle the physically demanding and repetitive tasks, human ingenuity and decision-making remain irreplaceable. The collaboration between humans and robots isn't just complementary, it's essential for the success of building cities on the moon. One of the biggest challenges in this partnership is remote collaboration. Astronauts on the moon would need to work seamlessly with robots, often in real time, despite the vast distances and communication delays with Earth. This is where teleoperation comes into play. Imagine a human operator on the lunar surface controlling a robot's movements with precision, using advanced interfaces to guide it through complex tasks. This hands-on approach ensures that robots can adapt to unexpected challenges, leveraging human problem-solving skills on the spot. But it's not just about direct control. Humans will also play a critical role in oversight and strategy. Think of it as a partnership where robots are the workforce and humans are the project managers. Astronauts would monitor robotic activities, analyze data, and make high-level decisions to optimize efficiency and safety. For example, if a robot encounters a problem it can't solve on its own, a human could step in to provide guidance or reroute it to a different task. This collaboration also extends to scientific exploration. Robots could be sent to collect samples or investigate hazardous areas, while humans interpret the findings and decide the next steps. It's a dynamic relationship where technology amplifies human capabilities, allowing us to achieve more than either could alone. The key to making this partnership work lies in designing intuitive systems that bridge the gap between human and machine. Advanced AI can help by learning from human input, improving its ability to anticipate needs and execute tasks independently over time. Meanwhile, astronauts will need training to master these tools, ensuring they can work effectively alongside their robotic counterparts. In this futuristic vision, humans and robots aren't competitors, they're teammates. Together, they'll turn the dream of lunar cities into a reality, proving that the greatest achievements come from collaboration. Imagine trying to build a structure in a place where temperatures swing dramatically from scorching heat to freezing cold, where there's no atmosphere to protect you from radiation, and where tiny space rocks can strike with the force of a bullet. This isn't science fiction, it's the reality of construction on the moon. One of the biggest hurdles is the constant bombardment of micrometeorites, which can damage equipment and pose a threat to any structures being built. To tackle this, AI-powered robots are equipped with advanced materials and self-repair systems, allowing them to detect and fix damage in real time. These robots are also shielded against extreme temperature fluctuations, ensuring they can operate reliably in the moon's harsh environment. Another critical challenge is the moon's lack of a protective atmosphere, which exposes everything on its surface to high levels of cosmic radiation. This isn't just a problem for human astronauts, it can also interfere with the electronics and software of robotic systems. To address this, engineers have developed radiation-hardened components and algorithms that allow AI-driven machines to adapt and function even under intense radiation exposure. These innovations are crucial for ensuring that lunar construction can proceed without interruption. But it's not just the physical environment that poses challenges. The psychological and logistical aspects of working in such an isolated and unforgiving setting are equally daunting. For human crews, the isolation and distance from Earth can take a toll on mental health, while robotic systems must operate with minimal human oversight due to the communication delay between the Moon and Earth. AI-powered robots are designed to work autonomously, making decisions on their own and collaborating with other robots to complete complex tasks. This level of independence is key to overcoming the logistical challenges of lunar construction, ensuring that progress continues even when direct human intervention isn't possible. Overcoming these obstacles isn't just about engineering marvels, it's about paving the way for humanity's future in space. Each challenge met and solved brings us one step closer to establishing a sustainable presence on the Moon, turning what once seemed impossible into a tangible reality. When we think about building cities on the Moon, it's easy to focus solely on the technological marvels involved. But here's something we can't overlook. Even in the harsh, barren environment of the Moon, sustainability is crucial. AI-powered robots aren't just about efficiency and speed. They're also key players in ensuring that lunar construction is environmentally responsible. After all, the Moon's landscape is unique and fragile, and how we build there will set a precedent for humanity's future in space. One of the most exciting ways AI robots can contribute is through advanced recycling systems. Imagine a robot that doesn't just build structures but also collects and repurposes materials from lunar soil and discarded construction debris. This isn't science fiction. Scientists are already exploring how to extract metals, oxygen, and even water from the Moon's regolith. By recycling these resources, we reduce the need to transport materials from Earth, which is not only costly but also energy intensive. It's a win-win for efficiency and environmental stewardship. Then there's the issue of waste. Building a city, even on the Moon, inevitably generates waste. but AI robots can be programmed to minimize this by optimizing material usage and finding creative ways to repurpose excess. For example, leftover materials could be used to create storage units, protective barriers, or even artistic installations that enhance the lunar city's aesthetic. This approach ensures that nothing goes to waste, aligning with the principles of a circular economy. But sustainability isn't just about materials and waste, it's also about preserving the moon's natural environment. The moon's surface has geological features that are billions of years old, and disturbing them carelessly could erase a piece of cosmic history. AI robots can be equipped with sensors and algorithms to identify and avoid sensitive areas, ensuring that construction respects the moon's natural beauty. Think of it as space conservation, where every decision is made with the long-term health of the lunar ecosystem in mind. By integrating sustainability into every step of lunar construction, we're not just building cities, we're creating a model for responsible exploration and habitation. It's a reminder that even in the vastness of space, our actions have consequences, and it's up to us to ensure that our footprint is as light as possible. This is how we pave the way for a future where humanity thrives beyond Earth without sacrificing the environments we call home. Building cities on the moon might sound like something straight out of science fiction, but let's talk about the economics of it. Is this ambitious endeavor actually worth the astronomical costs? The answer lies in a mix of innovation, resourcefulness, and long-term thinking. First, consider the funding sources. Governments, private companies, and international collaborations are already pooling resources to make lunar exploration a reality. NASA's Artemis program, for instance, has set its sights on returning humans to the moon, while private entities like SpaceX are pushing the boundaries of space infrastructure. But funding is just one piece of the puzzle. What about the returns on such a massive investment? Enter lunar tourism and resource mining. Picture this: wealthy adventurers paying top dollar for a once-in-a-lifetime trip to a moon city, or mining companies extracting rare metals and helium-3, a key ingredient for future fusion energy. These potential revenue streams could not only offset costs but also create entirely new industries. Now, here's where AI-powered robots come into play. These machines could drastically reduce the expenses of lunar construction by handling dangerous, repetitive, and labor-intensive tasks autonomously. Think about it: no need to transport large crews or build extensive life support systems for humans. Robots can work tirelessly in the harsh lunar environment, building habitats, laying infrastructure, and even maintaining operations with minimal human intervention. By cutting down on labor and safety costs, AI-driven automation could make lunar cities far more economically feasible. But let's not forget, this isn't just about short-term gains. Establishing a presence on the moon opens the door to further space exploration, scientific breakthroughs, and even the possibility of a self-sustaining off-world economy. The economic viability of lunar cities isn't just a question of cost, it's an investment in humanity's future. When we think about building cities on the moon, it's easy to picture a single nation or company leading the charge. But the reality is far more inspiring. Space exploration is a collective effort that transcends borders. This isn't just about one country or organization. It's about humanity coming together to achieve something monumental. The vision of lunar cities isn't just a technological challenge. It's a test of our ability to collaborate on a global scale. Countries around the world are pooling their resources and expertise to make this dream a reality. Take, for example, the Artemis Accords, an international agreement spearheaded by NASA but supported by nations like Japan, Canada, and several European countries. These accords outline shared principles for sustainable lunar exploration, emphasizing transparency, interoperability, and peaceful cooperation. It's not just about planting flags, it's about building a framework where everyone benefits. Private companies are also playing a crucial role in this collaborative effort. SpaceX, Blue Origin, and other innovators are working hand in hand with governments to develop the technologies needed for lunar construction. Imagine a future where robotic systems designed in one country are manufactured in another, using materials sourced from yet another, all working in harmony to build the first lunar habitat. This level of global cooperation isn't just impressive, it's essential. The challenges of building on the moon are immense, from the harsh environment to the logistical hurdles of transporting materials across space. No single entity could tackle these obstacles alone, but by sharing knowledge and resources, we can overcome them together. Think of it like a giant puzzle. Each country and company brings a unique piece, and only by fitting them together do we see the full picture. And let's not forget the broader implications of this collaboration. When we work together on the moon, we're not just solving technical problems, we're building trust and setting a precedent for future endeavors in space and beyond. The moon could become a symbol of what humanity can achieve when we unite around a common goal. It's a reminder that, even in the vastness of space, we're stronger together. As we set our sights on the moon as a new frontier for human expansion, it's impossible to ignore the ethical questions that come with such a monumental endeavor. Who really owns the resources on the moon? Should we treat it as a blank slate for development, or are there boundaries we need to respect? These aren't just hypothetical questions, they're critical conversations we need to have as we deploy AI-powered robots to build lunar cities. One of the most pressing ethical concerns revolves around the ownership and use of lunar resources. While treaties like the Outer Space Treaty of 1967 declare that no nation can claim sovereignty over the moon, they don't address private entities or the extraction of materials. If robots mine and construct using these resources, who benefits? Will it be a collaborative effort for humanity, or could it lead to a new kind of resource inequality? These are questions that demand clear, thoughtful answers before we proceed. Another layer of complexity involves the rights of future lunar inhabitants. If we establish permanent settlements, how do we ensure the well-being and autonomy of those who choose to live there? Will they have a say in how their cities are designed or governed? And what about the AI systems making decisions on their behalf? While autonomous robots can streamline construction and maintenance, we must consider the implications of ceding too much control to machines. Striking the right balance between human oversight and AI efficiency is essential. Ethics must be at the core of every decision as we take these bold steps into space. It's not just about what we can do, but what we should do. By addressing these questions now, we can pave the way for a future that's not only technologically advanced but also morally responsible. As lunar cities begin to take shape, thanks to the tireless work of AI-powered robots, it's hard not to wonder what lies beyond the moon. The technology and systems being developed for these lunar outposts aren't just about creating a foothold on our nearest celestial neighbor, they're laying the groundwork for something far grander. Imagine these same robots equipped with even more advanced AI, venturing out to Mars and beyond. The moon is just the first step in humanity's journey to becoming a multi-planetary species. One of the most exciting possibilities on the horizon is the concept of self-replicating robots. These machines could use raw materials found on the moon or Mars to build copies of themselves, exponentially increasing their workforce without requiring constant resupply from Earth. Picture a team of robots landing on Mars, mining its resources and constructing habitats, laboratories, and even more robots, all while operating autonomously. This self-sustaining system could drastically reduce the cost and complexity of interplanetary colonization. But it's not just about the hardware. The AI systems driving these robots are evolving at an astonishing pace. Advanced machine learning algorithms could enable robots to make real-time decisions, adapt to unpredictable environments, and even collaborate with human astronauts in ways we've only seen in science fiction. These intelligent systems could handle everything from routine maintenance to complex problem-solving, ensuring that human explorers can focus on the bigger picture. Looking further ahead, the lessons learned from building lunar cities could transform our approach to space exploration. The moon serves as a testing ground for sustainable living, resource management, and long-term survival in harsh environments. These insights will be invaluable as we aim for Mars and potentially even more distant worlds. The dream of a multi-planetary future isn't just a lofty ideal, it's a tangible goal within our reach, driven by the innovations we're pioneering today. As we stand on the brink of this new era, it's clear that the possibilities are limitless. From self-replicating robots to intelligent AI systems, the tools we're developing today are the building blocks of tomorrow's interplanetary civilization. The moon is just the beginning, and the future is waiting for us to take the next bold step. The pace of technological advancement is nothing short of extraordinary, especially when it comes to AI and robotics. As we look toward the future of lunar construction, a host of groundbreaking innovations are poised to redefine what's possible. One of the most exciting developments is the rise of swarm robotics. Picture this: hundreds, even thousands of small, autonomous robots working together in perfect harmony, like a colony of ants building a complex structure. These robotic swarms could tackle massive projects, from laying lunar foundations to assembling habitats with unparalleled efficiency. Another game changer on the horizon is quantum computing. While still in its early stages, quantum computing has the potential to revolutionize how AI-powered robots process information. Imagine machines that can solve complex problems in seconds, problems that would take traditional computers years to crack. This leap in computational power could enable robots to make faster, smarter decisions on the lunar surface, optimizing every aspect of construction in real time. We're also seeing advancements in self-healing materials, which could be a game changer for lunar infrastructure. These materials repair themselves when damaged, reducing the need for constant maintenance, a critical factor in the harsh environment of space. Combine this with AI algorithms that can predict and prevent structural failures, and you've got a recipe for long-lasting, resilient lunar cities. And let's not forget about 3D printing technologies, which are evolving at a rapid pace. AI-driven 3D printers could use lunar regolith, the dusty soil found on the moon's surface, to construct everything from roads to entire buildings. This not only reduces the need to transport materials from Earth, but also makes lunar construction more sustainable and cost-effective. Each of these innovations represents a piece of the puzzle, working together to bring humanity closer to a permanent presence on the moon. What's truly exciting is how these advancements complement each other, creating a synergy that accelerates progress in ways we're only beginning to understand. The future of lunar construction isn't just about building structures, it's about building possibilities, and the innovations on the horizon are paving the way. When we look at the way we build on Earth, it's impossible not to see the parallels that could guide us in constructing cities on the moon. Earth-based construction has given us a treasure trove of techniques that could be adapted to the lunar environment, starting with the concept of prefabrication and modular design. Here on Earth, these methods have revolutionized how we construct skyscrapers, hospitals, and even entire neighborhoods by creating components off-site and assembling them quickly and efficiently. On the moon, where resources are scarce and conditions are harsh, this approach could be a game changer. Imagine shipping pre-built modules from Earth or fabricating them locally using lunar materials, then snapping them together like cosmic Lego bricks to create habitable structures. It's not just about speed, it's about precision and minimizing risk in an unforgiving environment. But the moon isn't just a blank slate. It's a place where Earth's construction challenges are amplified. Take extreme temperatures, for example. On Earth, we've developed insulation and climate control systems to handle the coldest winters and hottest summers. On the moon, where temperatures swing from -280 degrees Fahrenheit at night to 260 during the day, these systems would need to be far more robust. Another challenge is seismic activity. While the moon doesn't have tectonic plates like Earth, it experiences moonquakes caused by gravitational forces and cooling of its interior. Earth's earthquake-resistant designs could inspire lunar buildings that can withstand these unexpected tremors. Then there's the question of sustainability. On Earth, we're increasingly focused on green construction using renewable materials, reducing waste, and designing energy-efficient buildings. These principles are even more critical on the moon, where every resource is precious. Lessons from Earth's push toward sustainability could inspire lunar construction that minimizes waste, recycles materials, and harnesses renewable energy sources like solar power. After all, the moon has no atmosphere to block sunlight, making it an ideal location for solar energy. By studying Earth's construction successes and failures, we can create a blueprint for lunar building that's both innovative and practical. The challenges we face here provide a roadmap for overcoming the obstacles we'll encounter on the moon. It's a reminder that our future in space isn't just about leaving Earth behind. It's about taking the best of what we've learned and adapting it to new frontiers. When we talk about building cities on the moon, it's easy to focus on the robots, the machinery, and the groundbreaking technology. But there's something even more powerful at play here: the ability to inspire. Think about it. A human settlement on the moon isn't just a feat of engineering. It's a symbol of what's possible when we dare to dream big. And for the next generation, that symbol could be the spark that ignites a lifelong passion for science, technology, engineering, and mathematics, or STEM. Imagine a young student watching a live stream of robots assembling the first lunar habitat. What might they see? Not just wires and metal, but a future where they could be the ones designing the next generation rover, writing the code for a lunar power grid, or even stepping onto the moon themselves. Projects like these have the power to transform how young people see their place in the world. They don't just teach science, they make it exciting, tangible, and full of possibility. Education and outreach are key to unlocking this potential. Schools, institutions, and even online platforms can play a huge role in connecting young minds to these groundbreaking projects. Imagine interactive programs where students can virtually control a robot on the moon, or workshops where they learn to design their own lunar habitats. These experiences don't just educate, they empower. They show kids that the skills they're learning in the classroom today could one day help build a city in space. And it's not just about the technical skills. Projects like this teach resilience, creativity, and the importance of collaboration, lessons that are just as valuable as knowing how to calculate orbital trajectories. When students see the challenges of building on the moon, they learn that failure is just a stepping stone to success. They learn that solving big problems takes teamwork, innovation, and the courage to keep trying even when the odds seem impossible. Ultimately, inspiring the next generation isn't just about creating future engineers and scientists, it's about shaping future dreamers. It's about giving them the tools to see beyond the horizon, to believe that they can be part of something bigger than themselves. And as we take these first steps toward building cities on the moon, we're not just constructing habitats, we're building a legacy that will inspire generations to come. As we bring this exploration to a close, it's worth pausing to truly appreciate the monumental strides we've made and the possibilities that lie ahead. Imagine a future where AI-powered robots are not just building cities on the moon, but paving the way for humanity to thrive in the cosmos. The challenges we once thought insurmountable, like extreme temperatures, lack of resources, and the vastness of space, are being tackled head-on by cutting-edge technology. What once seemed like science fiction is now within our grasp, and the implications are nothing short of transformative. The moon is more than just a stepping stone, it's a proving ground for innovation. Every robotic arm that shapes lunar soil, every AI algorithm that optimizes construction, and every habitat that rises from the barren surface is a testament to human ingenuity. But this is only the beginning. The lessons we learn here will propel us further toward Mars, the asteroids, and beyond. The stars are no longer out of reach, they are our next frontier. Thank you for being a part of this journey into the future. If this vision of tomorrow excites you as much as it does us, don't forget to like this video, subscribe for more content, and share your thoughts in the comments. What do you think humanity's next great leap will be? Together, we can dream bigger, reach farther, and explore the wonders that await us among the stars. As we look toward the horizon of what's possible, the idea of AI-powered robots building cities on the moon becomes more than just a vision. It's a stepping stone to a future filled with limitless potential. If this glimpse into the future has sparked your curiosity, there's so much more to discover. Dive deeper into the world of futuristic technology by exploring our other videos, where we explore groundbreaking innovations that are shaping tomorrow. Don't miss out on the latest breakthroughs. Subscribe to our channel and join us on this exciting journey. Together, we can imagine and create a future where the moon is just the first chapter in humanity's incredible adventure among the stars. Let's take that next step together.